All right, we are going to take what we know about similar triangles and apply it to a situation that comes up with right triangles. And this involves the altitude of the triangle, which is a concept I'm sure you've dealt with before, except you might have referred to it as the height. So often when you're trying to find the area of a triangle, you find the height of the triangle. And then you take base times height and then multiply it by 1/2 or divide it by 2. But the altitude or the height is this line that you draw from one of the corners, from a vertex of the triangle to its opposite side. So like this blue line segment on the triangle on the left here. And a height always hits that opposite side at a 90-degree angle. It is perpendicular to that side. So when we have right triangles and you draw an altitude or a height from the right angle to the opposite side, the hypotenuse, what you get is you get two triangles that are similar to the triangle you started with. And I'm going to run through really quick how we know that and how that works. So if you look at this triangle again on the left, this diagram here, you have this little triangle. And I want to take this little triangle and compare it to the big triangle that we started with, the whole thing. So this little triangle, it has a right angle right here. The big triangle that we started with has a right angle up here. We also have this angle in the lower right-hand corner, which happens to be a part of the little triangle and the big triangle that we started with. So that gives us two pairs of congruent angles, the right angle and then this angle that both triangles share. So by angle, the little triangle on the right side is similar to the entire triangle. Let's look at the other triangle, the one on the left. It's a little bit bigger, this triangle right here. We have the same deal. Because we made an altitude, it hits at a right angle. So this triangle that I just outlined in green has a right angle. We already know the original triangle we started with also has a right angle. And then this angle in the lower left is part of both triangles. It's shared by both triangles. So again, we have two pairs of congruent angles, the right angles and then the angle that they share. So by angle, the green triangle that I just outlined is similar to the big triangle. And so if the green triangle and the red triangle are both similar to the big triangle that we started with, that means they also have to be similar to each other. So when you draw an altitude on a right triangle that goes from the right angle to the hypotenuse, you end up with three similar triangles, the two new triangles that you created, and then the original triangle that you started with. So what we've been doing with similar triangles is proportions. Once you know two triangles are similar, you can use some of the information you have to find out more information about the lengths of the sides. So here it says A over X equals X over B. So look at the green triangle and the red triangle. On the green triangle, the two legs of the triangle, and when I say legs, I'm talking about the sides of the triangle that meet at a right angle. So the sides that are not the hypotenuse. So our legs are A and X. A is the longer leg, X is the shorter leg. So if we make a fraction, A over X, so that's the long leg over the short leg, then that has to be proportional to the same fraction from the red triangle. So again, we've got two legs on the red triangle, B and X. On the red triangle, X is the longer leg, so that's going to go on top. And B is the shorter one, so it goes on bottom. So we have long leg over short leg equals long leg over short leg. So just the same thing we've been doing, just it's going to look different because it's a new situation, but it's the same idea. If you look at this one on the right, it's a little more complicated, but the same thing's going on. So here we are taking one of the little triangles and comparing it to the big triangle. So if you look at our first fraction, you have D over A. So we're looking at this triangle right here. And on that triangle, D is the longer of the legs, And A is the hypotenuse. A is the side that's across from the right angle. It's the longest side of the triangle. So it's the hypotenuse. So think back to when we did Pythagorean theorem. That's what we're talking about here. So you have the longer leg over the hypotenuse. Now let's look at the entire big triangle, so the whole thing. Well, if you look at this big triangle, the legs are A and B. So the longer leg is going to be A. Then the hypotenuse is this side right here, which includes D and C. So your hypotenuse is going to be D and C together, D plus C. So that's your hypotenuse. And then you can do the same thing. The one here they have on the bottom right, they did the exact same thing with this little triangle, comparing it to the entire triangle. So if you're a little confused on that, just follow along with the examples. I think it'll make more sense once we have actual numbers to put with this. So here's our first example. It says solve for x rounded to the nearest tenth. So what we're going to do is we're going to take the two triangles that we get when we put this altitude down the middle here. So that we got a triangle on the right, triangle on the left. And let's start with the one on the left. The two legs are x and 27. So we're going to make x over 27. X is the short leg, 27 is the longer leg. Now we're going to make a fraction with the triangle over here on the right. So here on the right, the short leg is 9. The longer leg is x. So this is very similar to things we've done already. It's just the two triangles are like right up against each other. So we have x over 27 equals 9 over x. Now we cross multiply to solve it. And here's what's going to happen that's different than what we've done so far. When we take 27 times 9, 27 times 9 gives us 243. But when we cross multiply the other way, we have x times x. Well, x times x is x squared. So we have x squared equals 243. So now to solve this, and again, this goes back to stuff we did when we did Pythagorean theorem early in the year. The way you get rid of a squared and just you figure out what x is you take its square root. So we're going to take the square root of x squared. We're going to take the square root of 243, because whenever you do something to one side, you always do it to the other. So the square root of x squared is just plain old x. So now I'm going to take the square root of 243. I like to use the Google calculator, but you're free to use any calculator. But you will need to use a calculator for this. So I'm going to hit my little square root button here. And 243. And I get approximately 15.588. I believe this said to round to the nearest tenth. So that's one place after the decimal. So this is going to be 15.6. 15.6. So let me bring my pen back here. So we have 15.6 approximately. Let's do another one. Very similar to that one, just to get a feel for it. So what I've got here is on the triangle on the left, I have the x and the 6. Those are my two legs. The x one is the shortest of the two legs. The 6 is the longer. And again, it doesn't matter which way you set it up as long as you're consistent. So I did short leg over long leg. So when I go to the other triangle, I'm going to have the same thing. Short leg is the 3. The long leg is the x. One thing you'll notice is when you have this situation that we've had on these last two problems, when you set it up, if you do it correctly, you should have the x on top on one fraction and on bottom in the other fraction. They should end up in opposite places if you do this correctly. So I'm going to cross multiply again. X times x is x squared. 6 times 3 is 18. And then again, to solve it, I have to take a square root. So I take the square root of x squared, and I take the square root of 18. The square root and the square cancel out. So I just get plain old x equals. Then you go to your calculator, type in square root of 18. It's approximately 4.2. Again, we're rounding this off to the nearest tenth. So one place after the decimal. All right, let's look at one that's a little bit different here. So here we have the x that we're trying to solve for, and then we've got a 12 and a 2. The x is in a different position than it was in the last couple problems. So here's what I want to look at. I have this little triangle here, and I know two of the sides. I know one of the sides is x, and one of the sides is 2. So I'm going to go ahead and set up a fraction. And you can do x over 2 or 2 over x. It really doesn't matter. Let's do x over 2. What I need to think about is, what does each of those things represent? So x is the hypotenuse of this little triangle. So if you look at the little triangle, the right angle's right here. The x is the side across from the right angle. It's the longest side of the triangle, so it's the hypotenuse. The 2 is the short side of the triangle, so it's going to be the shorter leg. So now I got to set up a second fraction. And to do that, I really don't know anything about this triangle over here on the left, except that one side is 12. I don't know anything about the other two sides, so I can't really use it. So the thing I have to do now is I have to look at the big triangle, the whole thing. And if I look at the fraction I already set up, I have the hypotenuse and I have the shorter leg. So those are the two things I need, the hypotenuse and the shorter leg. Well, if you look at the big triangle, so just ignore this line in the middle. You look at the big triangle, the shorter leg is x. So short goes on bottom, that's where the x goes. What's the hypotenuse? Well, the hypotenuse of this big triangle goes from here all the way to here. So it's the 12 and the 2. So I have to put those together. So I'm going to take 12 plus 2, and it's going to be 14. So now I've got it set up. Hypotenuse over the shorter leg equals hypotenuse over the shorter leg. I will cross multiply. I will get x squared equals 2 times 14. That's 28. I will take the square root. That gives me x. Again, you would have to go to a calculator and punch in square root, hit the little square root button and type in 28, and you should get approximately 5.3. So x is about 5.3. One more problem to look at. This is like it's not really a word. I guess there are words, so technically it is a word problem, but it's a situation here where we have this lake. We know a little bit about some of the measurements near the lake, and we're going to use those to figure out the distance across the lake. So this is a right angle. This that we're looking for from here to here is going to be our x. So again, we need two triangles, and we need to have two sides of both triangles. So if I look here, the triangle on the right, I have the two legs. I have x and 6. So I'm going to go x over 6. X is the long leg. 6 is the short leg. So now I'm going to set up my other fraction. And it looks like the other triangle where I'm going to have enough information to work with it is this one on the left. So remember, to do anything, you have to have information about two of the sides. And I know two of the sides. I have 4 and 6. So I did long over short. So I take the long leg, which is 6. That goes on top. The short leg is 4. It goes on bottom. So now I can cross multiply. And this one's actually going to work out a lot more nicely than the other three did, because I only end up with one x. So I have 4 times x is 4x equals 6 times 6 is 36. So even on this situation, you don't always end up with x squared. You don't always have to take a square root. That's something that can happen, but it's not always going to happen. It's going to depend on the problem. So now we have 4x equals 36. We'll divide both sides by 4. And 36 divided by 4 is 9. We get x equals 9. So this lake is 9 kilometers across. So that is how we use these right triangles and what we know about similar triangles to find some of these missing distances. And keep in mind, most of this is just doing the same stuff we've been doing. The one thing that's new is that sometimes you'll get an x squared, and then you'll have to take the square root to be able to find your answer.